Good afternoon, everyone. Sorry about the technical delays and stuff. Usually happens every time when we've got technology involved, right? So everyone, thanks for joining this IO Extended. It's already probably late, but thanks for being here, and I appreciate your time. My name is Kushal, and I'm going to be the presenter for this session. I'm going to talk about healthcare and AI, and so a little bit of a rule book where we start with nice quotes. So quote to get you started with, any sufficient advanced technology is equivalent to magic by Arthur C. Clarke. So about me a little bit. I'm a research assistant at University of Newcastle, working on a team called Knowledge Engineering and Research team, and as well as I'm a lecturer and a research assistant for a college called AI Edge in Sydney. I'm also an IT professional, which is out of the scope, but I've been working in IT for the last 5 years now. I've been working as network support engineer, moving up to senior network and systems engineer role. So I would consider myself as a digital nomad, and M-shaped IT professional, which means that I have multiple streams of expertise, or I have multiple streams of passion, which I have expertise on, and specializing in ML, of course. So I'm just getting started with this presentation scene and tech talks. So there are a couple of talks that I've done before. One of them is from Google GDC Cloud Sydney Meetup, and the other one was GDC Cloud Sydney Meetup as well. And this would be the third talk. Not good, not bad for a start. Okay, not bad for a start. Okay, now, so this talk will be about AI in healthcare. I wanted to ask you about how many of you guys have healthcare experience, or somebody who are working in healthcare, probably something to do with derma. Anybody has any experience with that? Yes, that's great. So you know that it's a big problem. So you know that it's a big problem in Australia. You know why? Because it's harsh sun, right? The sun loves us, right? So it's basically what it means is that in terms of skin detection, there are a lot of cancer, or there are a lot of studies that's going on, but in this case, I focus on skin diseases. Basically, 23 skin diseases have been identified by Melanoma Institute of Australia, by saying that these 23 diseases are the most, what do you call it? Like, it's the major skin diseases or problems that Australians face. Out of them, we focus on melanoma, which is probably the fourth one, which I'll show you on the slide here. So here, if you see on the third one, so these are all the results where you can see there, the melanoma comes third in terms of 15,000 plus. See there, the melanoma comes third in terms of 15,000 plus number of new cases. What does that mean? It means that every single time, I mean, it's also 2 years ago. But I mean, the record still doesn't change, probably still the same thing. We're not getting any colder, are we? But the thing is, this masters, where I wanted to do something about skin diseases, and I found out a project that I could do, and that could lead up to a conference paper. So this was published on a conference paper back in 2022, which basically deals with identifying 7 out of 23 skin diseases. All of those diseases out of those skin diseases where I'm going to have a hard time pronouncing it. It's really hard. I'll try my best, okay? But I'll try my best, okay? It's actinic keratosis, basal cell carcinoma, benign keratosis, dermatofibroma, melanocytic nevi, and vascular lesions. These 7 out of 23 diseases we worked on this project. That's the same slide. I just wanted to elaborate a little bit more so that you can see clearly. Now we move on to the visual representation of the model, which looks like this. It's based on autoencoder. Have you heard about autoencoder before? Anybody? Yeah. So unsupervised classification, autoencoder takes an image, and then basically with the representation of, they understands the image where it distorts the image, and then understands and actually remakes the image based on that distortion what it learned, and then the image comes back to on the same sort of format that it was. So for example, if you input some image, like one image right, and then you can see the other distorted image on the left. Right. So it's based on encoded and decoded network, and the images that are formed basically gives the model a good understanding, probably help in predicting the input images that we're going to test or train later. Right. So applications, right? So I want you guys to think about this, right? On the right side of the screen, you can see like what are the applications for ML or deep learning. We see these buzzwords: sweet seed, no more AI. I'm not going to use AI, but obviously ML, right? Deep learning, NLP, computer vision. These are the things that deep learning can do is to computer vision applications. One is clinical, one is industrial, or probably you can say administrative, right? At this point, we're focusing on clinical applications. I can tell you for now, I have three sort of use cases that we can use MLDL for clinical applications. If you guys have a skill, you can actually think about add it on this list. What we're supposed to like? What is the? So that's the whole purpose of this. Figure out that. So if you're passionate about something, figure out what you can do. Sort of at least in sort of your basis, in sort of your basis, in sort of your practice as well, as well as you probably could get better, as well as you probably could end up doing something good. So that was the whole purpose of this. So think about this. I'm going to give you like 5 or 10 seconds to think about or come up with something. Raise your hand if you have some sort of ideas, except for these 6. What do you think could be added? Don't focus on clinical applications at this point. Just throw out your words. Just throw out your words you think. The words you think able. That would be machine learning, deep learning, be able to help people. Not just the 6. Not just the 6. More than that. Come again. Prescription. Yeah. Yeah. What? Risk analysis. Risk analysis. That's good. Yeah. Who is that? Yeah, that is also good. Yeah, that is also good. I'm expecting something with genes. No? Okay. Genomes. No? Genomes. Okay. Yeah. Genomes. Yeah. You can also learn about genomes and DNAs. You can also see the patterns of DNA. All that stuff. Yeah, that's good. Just a bit of a mind tease. So this is how the autoencoder. This is sort of simple code sample for autoencoder. Where you have an input layer, you put a state on, you have an encoded layer where you actually put an input into a lower dimension representation, and then decode it with your activation function. And at the end, you just compile with an optimizer and a loss function, which is mean squared MSE at this point. So in this, I wanted to tell you about one interesting thing that happened here. So basically what happened is while I was doing this project, one of the supervisors or lecturers got interested in my project because it was aligned with something that he did in his PhD, which is called decisional DNA. So decisional DNA and set of experience knowledge representation means is that you you augment and put an intelligence on where, for example, if you start training a model, you train them with a certain data set. You start with a data set. You start with a data set. So probably let's see, okay, you got images of data. Yeah, let's start training that model with the amount of images. Then you start training that model with the amount of images that you have. The model learns on the images, but what about the irregularities on the images? So for example, irregularities would be like high, let's say, image resolutions, quality of the image, or probably those free images that I used in would not be feasible for a model to actually have a production grade, right? It cannot be a production grade model if you've not used a production grade data set. That's pretty much simple. How do you do that? So one way is to collaborate with. How do you do that? So one way is to have that data that they have done. So for example, let's say a clinical data, a tested and proven clinical data with real-time people. That can be done, number one. Number two, which can be done is to actually generate data. Right? How about, think about this, like for example, when you go into Gemini, or for example, stable diffusion. Have anybody heard about stable diffusion? Yeah. So you want to create something that you based on an image. So let's say one portion of that would be image to image. So you provide an image, and based on that, with a font, you rewrite it, and then get the output back. So that also would be another way to do it. So we did that in terms of when we didn't have the data, right data. So what we did was we enhanced our images, and that images were again fed up to the model, stable diffusion model, and to generate similar kind of images that can be retrained. Okay? Those things can be done. Now here, our system were started with just up to 2 to 4% of training. So for example, if you talk about any other supervised models, there'll be like a lot of data or a lot of images that was involved there. Our model, what it does, it starts with very less amount and then learns over time through unsupervised classification. So for example, we also add an augmented intelligence factor. But what we do is not just we train the model, we also test them and provide feedback with users. For example, users would be like experts who are dermatologists. Like you have a model where you input the pictures and you have 7 different classifications of diseases that you want to do. So for example, let's say actinic keratosis, you input an image, the model says actinic keratosis, but the image was melanoma. That's 100%, that's not an accurate assumption, right? So what we do is we provide a sort of like a learning algorithm where we actually put the model into experts for retraining. So for example, like let's say a thumbs up or a thumbs up down sign, where if you think this decision is not right, let's say a derma people will think this decision is not right, they can retrain the model based on whatever the disease was out of those 7 classifications. We'll show that in a little bit of a demo at the end. That's also what also helped me in terms of getting the accuracy right as well. So this way the model became dynamic, experience driven, and also that's a thing that we need in the world of tech, right? Now, so here's the sample data that you can see on the right side of the screen, which is basically the image that we have, and then the decoded image, the same thing that we explained earlier. Now, experiments confirmed unsupervised classification for detecting 7 out of 23 major skin lesions. Initial testing with a number of training images yielded a model for 80% accuracy, which is a modest accuracy, if I may say, but also lies in the expertise of skin disease specialists. So Melanoma Institute of Australia, and there was another professional whose name is Dr. Serene Liu. He helped us in terms of getting that exposure for experts to give us retraining. So he's working with the Melanoma Skin Institute for about 7 to 8 years now, and he's a professor at University of Sydney as well. So he helped me in terms of giving that expert approach when we try to give it to him to test it. They went back and came back and said, there are a lot of problems in this model. How are you going to solve it? I said, okay, I've got a plan where I can initiate an augmented intelligence algorithm where guys like you can help us give the right decision. So for example, if I ask Siri to give me something about Flutter, because he's an expert, he's definitely going to give you the right answer. Same thing about someone who's relevant to the industry or the phenomena, we can actually get an augmented approach or augmented feedback with them. So that immediately increased our model's accuracy from 46 of around 42 to 46 to 80, which is about 78 to 79%. So move on to this, which would be delta score of 1.33%. So if you heard about delta, it's the difference between the previous accuracy and the new accuracy. Basically, what that means is that the first iteration, let's say there's a 21 iterations of training that was done for 7 times. Every images were 21 images each, and every images yielded certain accuracy. And when you actually go on and more, the 7th iteration, you'll find that every single time the delta value increases, or you'll have a significant difference of delta value, which also we can call it 10%. So for example, the first iteration yields you about, we can't say it's a non-applicable, but the second iteration, let's say it yields about 26%, and the third iteration yields about 32%, the delta would be about 6%. Or the difference between the first and the second test. That's the delta. So our average delta was about 1.33% every single iteration, right? Which was on a right direction, obviously, because the accuracy is going up, right? Now, the internal working of the system would be this. So we'll have a sample data set and then a reconstructed image and sort of like a system workflow chart where you'll have a test set, data set and test set, training set, and then a data set, which is a Harvard data set that is free of use, and we used it through the Harvard data repository platform. We downloaded it. It's about 3 to 5 gigs of data and has about more than 10,000 to 20,000 images, but you definitely have to do your pre-processing and augmentations on it so that you can probably do some good projects with it. So we're going to show that on the last part where, so now I'm going to give you a little bit of a metrics that what we did and what we found here. So basically on the first training set where we used unsupervised classification, we got the first training experiment on the left, the second on the middle, and the third are based on AI experience. The AI experience means is the one that we did with augmentation. Now this is a quick video of how the workings of the system works.
This is where we start our application on UI. So the whole purpose of our presentation, this one for demonstration video. So once it's ready, go to the Flask link. So the development server is Flask, and we go to that link.
So this would be the UI of the system, and we're just trying to test the images with system. And what we do is basically all it is as simple as you put an image and then upload that image onto the model.
Flask link, where is Flask, and we go to that link.
And just a second, I just need to, sorry.
So this is our model. We have
data. So that's it.
Data here.
I'm just going to be really quick with this. I don't want to. Yeah. So here, what we do is upload this image, and it gives you sort of like what it is. It gives you a prediction. Now, for example, if you don't want or if you think that it is not good enough.
Melanoma.
So yeah. So let's go back to the.
So now let's say, for example, this one. So
you want to go and want to correct, and then basically upload the same image or the image that you want to, and you think that is, so these are, yeah, so for example, if it's a BKL, you want to go and retrain the system, will retrain it, and then pretty much after the training, yeah, and then once the training is done, you'll say, yep, and then you can either go back home or you want to train again, you can do it again. That's pretty much sort of like a UI of the system. Now, I wanted to go over to a few things about on the web, which is, I'm going to end this and I'm going to show you a few other things, which is actually based on this. So here's what the data looks like. The data set, this is what the data set is available. I just wanted you guys to know the, yeah, I am, but I'm not. Okay, just give me a second. Sure. There you go. Yeah. Tell me if you can see this screen. Help me. Yeah. So that's
so you want to show this?
This one to the guys so that they can see my data set.
Yep.
Where they can always go back and, yeah, that's the, okay. So that's where we got our data.
Just got to mute yourself on Zoom. Oh, sorry. It's sharing the wrong screen, mate. There we go. sorry, you just want to just give it 1 second. I just got to mute this microphone. You keep talking, mate. You keep talking.
Yeah. So this is where we got our data set from Harvard Database, and you can always go and it's for free. You can go and download it if you want to use it, and that's where the 7 classes are. It gives you a very well diverse images where as long as you have good data pre-processing and augmentation techniques, you can pretty much have a good data out of it. And also you can also regenerate like we did. So you can also have teams to pre-process your data and just have those images that are really good, and then pretty much do a region of interest on it, which is like a good augmentation technique that I can tell you, where you can actually go on and do a region of interest where you focus on the main image of, for example, melanoma. So if you want to see how melanoma looks like, I can show you where you can just okay. You can just go to images on melanoma on your phone, or you can go there. So what you need to do is basically what we did in terms of the first image was we didn't get any good accuracy. So what we did, we implied region of interest where we cropped in the region of interest of the image, and then after that we retrained the model, fed the model with those images, and then after that we started yielding good results. Meaning is that the other parts of the images basically were not necessary for the model to actually do anything. So basically because of that, it was resulting on our accuracy. So that's why what we did was we implemented a region of interest on the images so that model knows where to do. So for example, the region of interest was on center. It's like on the center of the image, and basically what we did was, if the melanoma is basically like a normal shape, it's a very free shape of a black, sort of like a brown on a black thing, which means is that it's not going to be necessarily a right shape. But usually when the photos are in the data set, it will be of a hand, right? So what you need to do is basically just go around and figure that melanoma, focus on that melanoma, crop on it, and then reduce that image and fit that model. Don't fit the hand. So what that means is, like, you have to just be curious in what kind of data you feed your model as well. That also is a very important thing. So pretty much that would be the end of my talk at this point. I'm glad if you have any questions, I'm more than happy to answer. Yes, so grayscaling was also the thing that we did. And I think we also, we did crops and grayscaling. Those were the 2 things that we actually did. Yeah. Anyone else? Yeah, please. So we used a pre-trained model before from before, which was trained on numbers and digits, and we retrained them, fine-tuned it in terms of the skin images based on the Harvard database. And then we used our augmented techniques, like I mentioned, in terms of getting that image to be a proper image, and then basically just try it out thing, a hit and trial, and then basically figure out that, oh, okay, we should not feed the model the whole thing. We need to crop around. So we had our team spend about a week to get that sorted, and then retrain them again, and we got our accuracy up to 80% from the 41 that we did in the first instance.
Could you have not used another model per day from images to keep that process done?
Yeah, of course, like you can go from ground up, it's up to you, but the thing is, like, it's easier for you to have a model that is already worked on images, right? But we didn't have the leverage of finding the exact model based on skin tones trained on. So what we did was, okay, let's grab a model that's based on numbers from 0 to 9. It identifies the shapes, it identifies what the numbers is, it's good at pictures. So what we'll do is we'll train it on for our cancer or carcinoma pictures. Let's see how it goes. And then when you did it, the first instance, it was on unsupervised mechanism, which gives us 40%. And then I told you we used the augmentation technique. And the second time around, we got it up to 78% on testing and 79 point something on training. Yes, please. So, for example, like it was not a clinical experiment, obviously, but obviously we worked with skin experts. Yeah. So you want, can you come again? Because you wanted to know the. Yeah. Seven iterations on each training. Yeah. Mm-hmm. Well, that's what I said. So it's a student conference. It's basically a student work that I did in my capstone project. But there was no there's no pathological report or something based on this. So, that's the thing. So if you talk about diagnostics, so yeah. But the thing is, we took the images that were available on public. So we took public data set to take the image, whatever the status of the image was, whatever the information that image was. I can show you in the website itself. There is no clinical source for this data set probably. If there is, there must be something on metadata, which I can show you right now in the screen, where you can go onto this website and you can find out all the metadata about the. So here you can see that these things can be found on the data set itself. So if you go onto this website, and then you'll be able to find out all the things. So you'll be able to find out the ground truth, the test images. So this is basically, we took the images in, but it's not a proper diagnostic, obviously. It's a student paper, so it's basically not a proper diagnostic thing. That could be some sort of like a future work. That's 100% sure. Yes, but that's sure. But that was not the part of the project. We didn't perform those things in the project.
I just have one question regarding TensorFlow. I know that Google has closed TensorFlow certificate. So my question is, what do you think about the future of TensorFlow services to system library like PyTorch? And my second question is for AI in healthcare. I know that there's some very big problems that relate to privacy and security. So we don't really want to share client or patient data in like a centralized model. So do you have any idea about
Yeah, the first question. The first question would be, yeah, you can actually go for alternate pathways rather than TensorFlow, maybe PyTorch or something like that. Second would be, yeah, that's the part of my PhD, which I'm trying to pursue, which is ethical AI. So, and basically human-based design pattern in AI. So maybe that ethicality in terms of images is not that I'm concerned with, but definitely those with generative AI I'm concerned with, where, like some of the models that gives you output are based on some of the authors, which never get the credit of the training data. You understand what I'm saying? Which means is that obviously there's ethical gaps that need to be filled. But in this case, what you see is like for patients, yes, we can actually accept for those who wants to participate, and for those who doesn't want to actually expose their data, probably will have to have some sort of like acknowledgements or something that they have to sign up, so that the organization who's going to deal with their pictures are not going to share any of the images, demographics, age, height, I don't know, skin color, tones, all that stuff, or that personal information to anybody. Sure, that's a really great question. Actually, the thing is like what we did in our augmented intelligence training is just a standard one where if you don't like the answer, you just got to go thumbs down. But that's actually something that I can consider in terms of like getting that onto FutureWorks 100%. Yeah. So you mean, just to get your understanding, you mean that to have direct outcomes and then based on that outcome you retrain the model again through augmented intelligence. Is that what you're saying? Like just like maybe this is some sort of out of those 7 I list diseases, like instead of thumbs down and thumbs up, probably something to change with some other source of retraining. Is that what you're saying?
So like if you're getting like a specialist to look at like these lesions,
Yeah.
then like they can give like their reasoning and it's not just like totally.
Yeah, true. Yeah, of course. In detail, more in detail, they can actually provide their feedback. That's true. But we have not done this in the project, but definitely we can see that overdoing in the future or from some sort of FutureWorks for my CV and health AI related projects.
Okay. If there's no more questions, yeah, let's thank
you.
Kushal.